Okay, May 17th, 2011. You guys are, technically the review page on the textbook is 378, and you can start doing work and take notes on 323 in your blue notebook. Chapter 6 review. We've gone back a couple pages. We're going to go to page 343. We're going to take up number 9, a Ferris wheel question. Possibly could be important to your test. So, I've duplicated the graph they give you in the textbook. We'll write down each question, okay? Question A wants to know diameter of Ferris wheel. So let's read the question, just so you know. So here's our graph. And they titled this with John's height. So John M's height. What's that? Online? We're recording. Oh, on 9. You said online. Okay. It says the graph shows John's height above the ground as a function of time. So, our y-axis deals with height, and because it is a function of time, our x-axis deals with time in seconds. Okay? So this is recorded in seconds, 30 seconds, 60, 90, 120. And our height is in meters. So we've duplicated the graph they have in the textbook. And the very first question says, what is the diameter of the Ferris wheel? So John is obviously on a Ferris wheel. And if you guys recall, Ferris wheels are what shape? Oh, that's embarrassing. Clearly circles. So I'm going to put a circle on the side just to try to make sense of what's going on here. First of all, where does John start? How high above the ground is he when he starts? 12 meters, okay. And is that the top of the Ferris wheel, the bottom? Right in the middle, okay. So let's assume he starts on the left side, right in the middle of the Ferris wheel. And we know that he is 12 meters above the ground when he starts, okay. What is the peak that this Ferris wheel gets to? 22. So we're going to call this 22 meters. And now what is this, 22 meters long, 22 meters high? So above what? Let's try the ground. What about the lowest point, or the trough? So we already got the peak. What's the trough? 2 meters. 2 meters above ground. And what will this point be here then? 12 again. Good. Okay. So very first question asks us for the diameter of this Ferris wheel. How can I solve the diameter of this Ferris wheel? Nino. Okay, and what would the radius be? How would I find the radius? And what is the amplitude? Okay, good. So we want a really roundabout way to answer that. Let's be technical like he said. If we find the radius of the circle, we can find the diameter. That's true. And we know that the radius is going to be equal to, what is it? Amplitude. Okay. We know we can find the amplitude by doing what? Good. So amplitude equation is our peak minus our trough divided by 2. So we know that equation. Good. So we had our peak, we'd already figured it out, was 22. And our lowest point at trough was 2 divided by 2. So this is going to be our, let's call it our A. All right. So A will equal 20 divided by 2. What is A going to be? 10 what? Meters. So 10 meters is our diameter? Radius. So how do I find diameter from radius? Times 2. Okay? There's no pi involved in that. Nothing. A radius, you guys need a little recap here. A radius is just half the distance across a circle. A diameter is the entire distance. So in order to find the diameter, we take the radius and we multiply it. We take this radius, multiply it by 2. So we now know that the radius, from what we looked at, we're going to call radius our r, okay? So diameter equals radius times 2. We figured out that our radius was equal to our amplitude, and our amplitude was 10. So we plug 10 in for r. Our diameter is going to be 20 meters. So this is good. We used a lot of our terminology, peak, trough, amplitude, to solve this. Ian pointed out a very easy way to solve this. If you had just taken the peak and subtracted the trough, you would have found the diameter of the entire circle. Okay? We didn't really need to divide by 2 to find the radius. The diameter was the entire part across. So 22 subtract 2 is, please tell me you know this. Thank goodness. 20. So the exact same as what we found before. Diameter of Ferris wheel, 20 meters. Good. Let's move on to B. Question B, what is John's initial height above the ground? So, initial height. Oh, that is not how you spell initial. Did we find it already? You tell me. Yeah, that's right. Initial height. When we drew our Ferris wheel, it's always good to draw a diagram on the side, try to make sense of what we're doing. That's right. We had already found the initial height. Initial height is right here. Or, on the graph, it is right there, our initial height. So, he is 12 meters above the ground. Real simple. 12 meters. C. At what height did John board the Ferris wheel? It would make sense that he boarded it at 2 meters. I guess if you think of a Ferris wheel, yeah. Technically, that's an arbitrary question because what if he did climb up a ladder? We don't actually know that he did. It logically makes sense that he boarded it at 2 meters. Okay? I won't ask you a question like that on the test, but I won't. But not without a little more clarification. Logical answer, it'd be at the trough, so at 2 meters, 6 feet above the ground. It'd be pretty hard to board it at 12 meters, but who knows if there was a ladder or not. Okay, how high above the ground is the axle of the wheel? Yes, here's a good question. Axle of the wheel. What are they referring to, axle of the wheel? The center point of the circle. When we draw that on our wave here, what's that also known as? Equation of the axis. Equation of the axis. Okay, so you're right. It's going to be at 12. That's going to be the middle of this. But I want you guys to remember how to solve for that. So we know this is going to be our equation of the axis. Equation of axis. Equation of axis. It's also axis of the wheel. And we know it's 12 meters above the ground. How else could I find that? Anyone else know? Ian? Yes. Okay. Equation of the axis is also our peak plus trough divided by 2. So try not to get those two confused for amplitude and equation of the axis. We're going to call this E of Q. Our peak was 22. Our trough was 2. 22 plus 2 is 24 divided by 2. Not sure why I'm writing on an angle. 12 meters. So that's another way we could have found the equation of the axis. Obviously, by looking at our graph that we've drawn, it's pretty easy to see that the middle of this wave is at 12 meters. But this is the mathematical way to solve it. 12 meters high. I'm going to ask you guys some additional questions. For instance, I would like to know how long a period is. 60 what? Seconds. This is measured in seconds. So an entire period, one way to think of it is going around the wheel. Not quite. Let's assume we start at 0. Okay? So we have our 0 right here. Now you guys have, I guess you haven't quite guessed, but you figured out it's 60. Okay? So I'll ask that question after. Another way to think of this is we're going around the wheel. At what time, so let's say it's our initial run. At what time am I at 12 meters to start? 0 seconds. So I'm going to put that in, I'll do it a different color just so we can tell here. 0 seconds. What time am I at 22 meters? 15 seconds. Good, Joseph. What about when I come back down again? 30 meters, 12 meters. Yeah, I gave that answer. 30 seconds. What about when I'm at 2 meters? 45. And finally, when we end the period or back at the same point, we're at 60 seconds. Good. So, let's write that down. The period of this Ferris wheel, we'll call this question E. Period of wheel was 60 seconds. Good. Glad we're able to draw that. That diagram on the side, if you guys can do this, say if you have a question maybe similar to this on a test, will become very helpful. You'll probably get a question, I would say, that wouldn't give you the graph, but gives you points, and you'll have to graph it yourself. How many cycles? 2. 2 cycles. So, when does this ride end? Two minutes, 120 seconds. Good. I'm glad you guys are able to see this. Some of you, at least the 3 in front of me. We'll call this F. There's 2 cycles. Ride lasted 120 seconds or 2 minutes. I'd like to know the domain and range of this. So domain is equal to, range is equal to. Let's start with the domain. Anyone know? X is all real numbers. Very good. If the ride lasts 120 seconds, the domain is X, all real numbers between 0 and 120. Okay? Oh, simple. What about the range of this? That's right. So Y is a set of all real numbers. Let's go back down again. It's easy. We just got to find the peak and the trough. So it's between 2 and 22. Does the depending what greater and less than signs you use. If you write them the other way, facing that way, then the peak would go first. They just have to make sense what you're doing, okay? So we know we're between 0 and 120 seconds. This ride exists. And we know it goes from the height of 2 meters to 22 meters above the ground. Finally, let's see what we're doing for time here. Oh. Question G, create a sine function for this graph. So in other words, it needs to say f at x or h at x because it's technically height equals sine x and k. We need some function like that.